In this video, I'm actually going to define the Laplace transform. So we denote it by a cursive L, and then our given function that we want to transform. And this is given by the integral from 0 to infinity, e to the minus st, f of t dt. So let's look at one of the most basic functions we have, f of t equal to 1. And let's see if we can find the Laplace transform of 1. This is the integral from 0 to infinity of e to the minus st times 1 dt. This integral is given by negative 1 over s, e to the minus st, and then we need to evaluate between our bounds. Evaluating the bound to infinity means we want the limit as n goes to infinity of minus 1 over s, e to the minus sn, and then minus, if we plug in 0, negative 1 over s, e to the minus 0 times s. The limit as n goes to infinity of e to the minus n is 0, so this whole limit right here will be 0. The double negatives here will make a plus. 1 over s and e to the 0 is 1, so the Laplace transform of 1 is going to be 1 over s. The next one I want to find is the Laplace transform of e to the alpha t. This will be the integral from 0 to infinity, e to the minus st, e to the alpha t, dt. We can go ahead and combine these two e's using properties of exponents. And I'm going to write this as e to the minus s minus alpha t dt. So as a quick note, the actual exponent will be negative st plus alpha t. And then I went ahead and factored out a negative t to make this s minus alpha. Integrating then gives me negative 1 over s minus alpha times e to the minus s minus alpha t, going from 0 to infinity. This is the limit as n goes to infinity of negative 1 over s minus a, or s minus alpha, e to the minus s minus alpha n, and then minus negative 1 over s minus a, or s minus alpha, times e to the 0. This whole limit here is once again going to go to 0 under a particular condition. So we're going to need the added condition that s is greater than alpha, so that this number here remains positive, and then the negative sign in front of it will mean this is e to the negative n. And then we have plus 1 over s minus alpha. So my actual Laplace transform is 1 over s minus alpha, where s is greater than alpha. So I do have a restriction for my domain on this one. The next one I want to do is the Laplace transform of sine bt. This will be the integral from 0 to infinity of e to the minus st sine bt dt. And I won't work this one out directly since it does involve a complicated integration by parts problem, but I will tell you the final solution is b over s squared plus b squared. On the other hand, if I want to find the transform of cosine bt, this one would be given by s over s squared plus b squared. Next, I want to look at the Laplace transform of this discontinuous function f of t. To do a discontinuous function, I'm going to have to use multiple integrals. My first integral is going to go from 0 to 5, since that's my first condition. I need e to the minus st times f of t, so 2 times e to the minus st dt. My next integral is going to go from 5 to 10, the next piece of this. And this will be 0 times e to the minus st dt. And the final piece, since t is greater than or equal to 10, will need to go from 10 to infinity. E to the minus st times alpha t, or times f of t, so e to the 4t dt. This is going to simplify the integral from 0 to 5 times 2 e to the minus st dt. This term here is going to go to 0, since the whole thing is just 0. And then we have the integral from 10 to infinity of e to the minus s minus 4t dt. When I integrate this first one, I will have negative 2 over s e to the minus st between 0 and 5. Integrating the second one, 1 over minus s minus 4 e to the negative s minus 4t between 10 and infinity. Evaluating at 5, this would be negative 2 over s e to the minus 5s, minus evaluating at 0, which would be minus 2 over s e to the 0. My next piece, I'll need the limit as n goes to infinity of negative 1 over s minus 4 e to the minus s minus 4t, or s minus 4n. And then I can subtract out when I stick in 10. Minus, so negative 1 over s minus 4 e to the negative 10 times s minus 4. As I evaluate this term here is going to be positive 2 over s, and then minus 2 over s e to the minus 5s, so I just moved it so that my positive term would come first. Once again, this limit is going to go to 0, provided s is greater than 4, so I do have a restriction on my domain once again. The double negatives here are going to cancel, and I have plus 1 over s minus 4 e to the negative 10 times s minus 4. And as we're working through this problem, we can see a lot of different pieces pop up. The 2 from the first piece of this function pops up in the numerator here. The e to the 4t pops up in the fact that there's a 4 in this exponent as well as a 4 in the denominator. And the fact that my discontinuous points are at 5 and 10 pop up as these exponents to e as well.